Hey everyone, welcome to the first week of Introduction to Unix and Linux. I'm Mark Troyer. I'll be your instructor for this semester. I'll tell you a little bit about me before we jump in. I've been a Unix and Linux systems administrator or DevOps engineer or server operations engineer or whatever you want to call it now for about 20 years. For the first 15 years, I was working on Solaris servers, and for about the last 5 years, I've been working on Linux servers. I've worked for big telecoms like MCI and Verizon. I've worked for small startups. Uh, Most recently, I've been working for a startup in San Francisco called Hipmunk. Um, well, a very small team of server operations people there, and it's been a lot of fun. I do this. I've done this career for 20 years because I really enjoy it and because I find Unix and Linux to be a lot of fun to work on, and I hope at the end of this that you do too. So let's talk a little bit about go over some of the basics for the semester, and then we'll talk about some of the history of Unix and Linux. So first we'll go over some of the basic class stuff before we get into the Unix and Linux material. There's all of the usual syllabus stuff. The syllabus is posted on Blackboard. If you haven't already, you should jump over there and go read through that. One thing that I've gotten a couple questions on, and I want to clarify is there are no books required for this class, but you will need to get a student membership to the ACM. The link is in the syllabus. And the questions I've gotten are about which of the student memberships to get. You're of course welcome to get any of the student memberships if the benefits look good to you. But you only need the basic $19 student membership to get access to the site and to all of the books and readings that we'll be doing for the class. Um, the schedule for the class, for our purposes, a week will be Tuesday through Sunday. So the lecture video and slides and that will be posted on Tuesdays. And then you'll have the rest of the week basically through Sunday night at midnight to complete any of the readings or quizzes, assignments, any of that. So I want to give you flexibility to work this class into your schedule as well. So we won't have you won't have to have a set meeting time and show up for this class. But watch the video and read through the stuff. Don't slack until Sunday night. That would be best. Um, just get it done on your schedule, but do get it done. There will be some adjustment to that schedule for the holidays, and the holiday for this semester would of course be Thanksgiving, and I'll post more about that as we get near to that. But you will have extra time that week to get things done. I won't make you work through the Thanksgiving holiday. So, and if at any point during the class you get stuck or you need some help, of course, use your resources. There should be lots of them available. There's all of the online materials, the books available with the ACM membership. And then, of course, one of the biggest places to get help would be the discussion board on Blackboard. Um, Post questions there, answer questions if you're able to, work with each other, and get the most out of the material that you can. Some things to remember when you are posting or sending email and asking for help. Getting help works better if you're clear and specific. You know, clearly say what you're needing help with or what you have a question on or where you're stuck. And especially when you're asking me a question, I do expect this is not an English class, but it is still a college class, and you're expected to write properly, standard written communication. Uh, no vague questions, no text speak, that sort of thing. Be clear with what you need. So just what is Unix? It means different things in different contexts, which we'll get into, but at its very base, what you think of as Unix is a form of operating system. There are many different types of Unix, but they are all basically, multi-user, multitasking operating systems. Um, the first version of Unix was created at Bell Labs in the 1970s. Um, and was made available basically for free. It was basically for free. There was a nominal fee to get the uh, the OS on discs or tapes or whatever, and so it was adopted quickly by educational institutions, universities, with the most notable one being the University of California, Berkeley. When you read through some of the older Linux materials or the histories, you'll see a reference to UCB Unix, and that is the University of California, Berkeley's version of Unix that they developed. Uh, it's been available in many commercial forms, and historically the Unixes were tied to a hardware platform. So a hardware manufacturer would have their version of Unix that ran on their systems. Um, some of the notable ones that uh, that you may hear of, some of them are still around. Are the Sun Microsystems Solaris, and Sun Microsystems was bought by Oracle, so now it's Oracle Solaris. Um, Sun Microsystems is another California form of Unix. Sun is actually an acronym that stands for Stanford University Network. The first version of the Sun's Unix was developed, and the hardware for it was developed at Stanford. There's the Silicon Graphics version, which was called IRIX. IBM had their version called AIX. Hewlett-Packard had HPUX. Digital Equipment Corporation, or DEC, had True64 Unix, which was also at various times called OSF1, AXP, or Digital Unix. And then Apple had pre-OS X, they had a different version of Unix called AUX, and of course now all of their machines run OS X. So while we refer to Unix as an operating system or a type of operating system or a different flavor of an operating system, what it really is it's a specification for operating systems. There's a big list of requirements that an operating system can meet and to be called Unix. Somewhere over the years, it became owned by a group called the Open Group. They own the trademark of Unix, and they actually provide the certification. So you have to go through the certification process to meet all the requirements, and then you can be called Unix. So, for example, if you're running on a MacBook or an iMac, any of the OS X computers, OS X has actually gone through the certification process and is actually a certified Unix operating system. Linux, on the other hand, while meeting all of the requirements, has not gone through the certification process. So Linux is technically not a Unix operating system. It's a Unix-like operating system. So other than being a Unix-like operating system, what is Linux? Like we said, it adopts all the requirements, but it hasn't been certified. At a very technical level, Linux is the kernel of the operating system. It's the very base of the operating system that controls all interaction with the hardware, and it's a scheduler of resources. On a bigger scale, the operating system is the kernel, which runs all interaction with the hardware, and the system tools which interact with the kernel to get things done. And then a distribution. So when you think of Linux, you think of Ubuntu or Red Hat or CentOS or one of those things. All of those are Linux, but what they are is a distribution, and a distribution is a package of the Linux kernel with specific system tools chosen by the distribution maintainers. Their installation and package utilities that they have created to go along with that, and then they package that all up into a distribution, and that's what you typically download and call your Linux operating system. So you could be running Ubuntu, you could be running Fedora. At the base, they're all the Linux kernel, but they will differ in their some of the system utilities and how they handle packages and installation. So the history of Linux is a much shorter history than that of Unix as a whole. While Unix has been around since the early 70s, the very early 70s, Linux began in 1991 in Finland at the University of Helsinki. It was a hobby project for Linus Torvalds. And so he worked on it by himself for a while and released various forms of the kernel. And then other people, he published it as open source code, and other people noticed his work and started adding on to it and began contributing to it. And then the GNU project ported its set of system tools to Linux. The GNU tools are available on pretty much basically on any of the Unix operating systems. You can get the GNU tools. They've been ported to that. But a lot of what you think of as the operating system when you're running a Linux system are actually the GNU tools that make the system work. All of the basic utilities really were ported from the GNU project into to run on Linux. So what does Linux do? Like I said, Linux is really the kernel of the operating system, and what the kernel is the heart of the operating system. It takes care of all of the interactions with your hardware, makes your OS actually operate. So it manages your memory, it manages access to your disk and your CPU and all your peripherals. It provides an abstraction layer for the hardware so that applications can be hardware agnostic. They can just ask the Linux kernel to deal with the hardware for them, and so it makes them much more portable. It provides for the security and isolation of users, making it a multi-user system, so each user has their own area, their own permissions, their own security limitations for what they can and can't do, and protection from other users. And, so you can have your files and your areas private to you and not readable by other users on the system. And it also provides the multitasking. So the kernel switches between the various tasks running on the CPU. So then there are system tasks and there are user applications, the two main forms of that. So the system tasks, the memory management and managing access to the disks and all of that. And then your user applications are the utilities you run from the command line, or if you're running with a graphic interface, it's managing all of those tasks. And it uses what is called preemptive multitasking, where the kernel itself manages access to the CPU resources, and it slices up the time and provides access to all of the different tasks. In previous versions of, say, the Mac operating system, before they switched to the Unix-based OS X, they used what was called cooperative multitasking, where multiple processes could run at once, but the process that was using the CPU had to actually give up the CPU to let the next process run, so badly behaved processes could commandeer the system and effectively make it a single-tasking system while it was running. So Linux distributions, the packaging of the install utilities and package management and system utilities and setup and all that. There are two major families of distributions. There are, of course, more than two families of distributions, but these are the two most widely used. There's the Red Hat form of Linux, which is kind of the standard set by Red Hat, and their commercial version, Red Hat Enterprise Linux, and then they have their free version, Fedora, which is kind of the experimental. That's where a lot of the things, the new utilities and new ideas show up in Fedora first. And then CentOS is the community enterprise operating system, which is based on Red Hat Enterprise Linux. They take all of the open source parts of Red Hat and compile them into a distribution called CentOS. And the CentOS project was recently actually bought and rolled into Red Hat. So they have Red Hat Enterprise Linux with all of their commercial tools and commercial support, and they now own CentOS, which is the community, fully open source and freely distributable version. And then there's Scientific Linux, which is also based on Red Hat, but is targeted more for, as you might guess, scientists. It's built to be, friendly and out of the box, ready to go for use in scientific labs and such. And then the other major family is the Debian family, and the two most widely used distributions in the Debian structure are Ubuntu and Knoppix, with Ubuntu being probably the most popular distribution of Linux right now, especially for desktop users. Ubuntu is historically focused pretty well on desktop users and personal users, so it's they've tried to make it a really easy to use form of Linux and really friendly for the desktop. But they also do have server versions and have a pretty good installed base on servers as well. So what kind of hardware do you need if you want to run a Unix or Linux operating system? Um, so at the very top end, you have what's called Big Iron. These are the really large, in some cases, multi-million-dollar servers that are generally, these are manufacturer specific, and they run expensive commercial forms of Linux on this hardware. So with Oracle, formerly Sun, you have their SPARC-based Big Iron servers, and those run either Solaris or you can get them with Linux. The IBM Power Systems, these are sort of they would be kind of mainframe class hardware, and they will run either IBM's AIX, Unix, or Linux. And then the HP Apollo systems, they're Big Iron, which used to run HPUX, and Hewlett Packard has kind of gone away from that in favor of Linux. And then you have the next step down from there, the enterprise class of servers. And these are generally Intel-based with some server-specific hardware. You have much more expensive and higher performing network cards and much higher performing disk controllers and disks that go in them. And these servers will run a variety of different types of Unix and Linux. So there's Solaris and FreeBSD and OpenBSD and NetBSD. And the BSD Linux Unixes are all based on the UCB Linux that came out of the University of California, Berkeley. And then, of course, these servers also run Linux. You have workstations and desktops. These like anywhere from custom built, PC towers and desktops down to laptops and iMacs, and those run primarily the versions you'll see on those are either OS X for the Apple hardware or Linux for the non-Apple PC hardware. And the same is true for laptops. For Apple laptops, the MacBooks and such, they'll be running OS X, and then for the non-Apple PC-based laptops, they'll primarily be running Linux. And then down from there, you have the single board custom hardware, things like the Raspberry Pi, embedded computer on a chip kind of thing. And the TiVo, actually, if you have a TiVo for connected to your TV, those run Linux. And then down to even smaller embedded devices and smartphones. So chances are, if you have a smartphone in your pocket, it's running some form of Unix or Linux. Android phones, Android is based on the Linux kernel, and then of course the iPhone runs iOS, which is an embedded form of OS X. So your iPhone or your Samsung Galaxy, they're both Linux computers in your pocket, or Unix computers in your pocket. So of course the question is, with any OS, which one is right for you, and which one should you run, or which one do you want to run? And so some things to help you decide that are, what will your system be doing? Does it need to run specific software packages? There are some commercial software that if you need to run them, will only run on certain types of operating systems. Some things now are written specifically for Linux. Some things, of course, are Windows only, and some things are OS X only. Do you need to have specific hardware for what it is you're doing? Do you need to interface with scientific testing equipment? Do you need video hardware? That sort of thing. who will be taking care of your computer? Is this a personal system that you're going to be completely responsible for, or is this a server hardware that's going to go in a data center and you have a team of people that will take care of it? And then how long does it need to be in service? How long do you think that you'll be running this computer with this operating system? Is this something you need, that's going to have a lifespan of 6 months, or does this need to be around for several years? So for non-Unix based operating systems, of course, the biggest option there is Windows. Windows comes in desktop and server versions. Um, it's typically had a pretty slow release cycle and a long maintenance cycle, meaning that major versions of the operating system don't come out very often, but they are maintained and supported for a very long time. New software and patches and security updates, and that will be provided for generally for several years. Um, these systems are historically have been primarily built around graphical user interface usage. Windows started out as a desktop system, and then moved into server versions of the operating system. And in the more recent versions of the Windows Server versions, the GUI components for the operating system are now optional. You don't need to install them at all on servers, whereas in the past, even on the servers, you had to install the full operating system and all of the graphical components. And now, especially with recent versions of Windows, the command line access to the servers especially, and the ability to do scripting on them to automate tasks has improved greatly. So for Unix-based operating systems, there are several choices, of course. There's OS X, which is primarily a desktop operating system. You see it mostly, on iMacs and Mac Minis and MacBooks. It's really, developed and targeted as a desktop operating system. But there is a server version available, and what the server version gets you is additional management packages for server tasks, better user management, like an LDAP server, which is like the Active Directory server on Windows, which is actually LDAP based, and then more utilities for managing the system from a server perspective, since it won't really be used as a desktop at that point. The OS X, of course, runs only on Apple hardware, and Apple currently has no dedicated server hardware. So typically, if you're going to run OS X server, you're either buying the really high-end Mac Pros for all the power, or what a lot of people do now is they'll run the Mac Minis as commodity servers, running the server version of the OS, and they just stack them up. They're relatively low powered compared especially to like the Mac Pro, but they're inexpensive, so you can get lots of them and use them in high availability or in clusters, that sort of thing. OS X is of course Unix certified. It is a real Unix trademarked operating system, and it has a fairly short release cycle of typically 18 months to 24 months. A new version is coming out. Another Unix option is Oracle's Solaris, which you have a couple choices there. It runs on specific big iron hardware. They're SPARC servers, which these are chips specifically designed, and Solaris is specifically historically written to run on them, and it's tuned really well for those chips, and they're very powerful. And now that especially that Oracle has bought Sun and owns Solaris, especially the SPARC-based servers, they've really done a lot of tuning on the operating system to make it extremely performant for running Oracle databases. But you don't have to stick with the SPARC hardware. Sun also, or Oracle also sells Intel-based, commodity server hardware, which runs the Solaris x86 version. And then they've also made that x86 version available as open source, so you can run it on just off-the-shelf commodity PC hardware. Although you'll find that if you're running Solaris, the x86 version of Solaris, you're going to find a lot less support for third-party software than you will for Linux. Much of the open source third-party type software is written for Linux, and the other commodity hardware Unix operating systems just don't have that kind of support. So Linux, which is technically not Unix, it's a Unix-like operating system. But one of the beauties of Linux is that it has been ported to run on almost anything. If there's something with a CPU in it, chances are somebody has ported or has tried to port Linux onto it. It's very strong as a server operating system. But when compared to something like Windows or OS X, it's not quite as mature for desktop use. But it's especially with the newer versions of Ubuntu and Fedora, it's getting there. But it's probably not quite something that you can set your grandmother down in front of and have her use as easily as say a MacBook running OS X. And with Linux, of course, once you choose to run Linux, then you have to choose a distribution. A lot of that is going to depend on what you need to run with it. What kinds of things you're going to be doing with it. Is it a server or a desktop? And do you need some of the really latest bleeding edge versions of some of the open source software, or do you stick with the more tried and true and really burned in and stable versions? Different distributions tend to focus on different areas and use cases, such as general desktop use, general server use, or scientific computing. And for some of them, commercial use or commercial support is available, but most of all the support for Linux distributions is volunteer based. Like unless you're using something like the Red Hat Enterprise Linux, which comes with a commercial support contract and all of that. So that's kind of a quick overview of the history of Unix and Linux and some of the differences and similarities with them. So for this week, your assignments are first a reading assignment, reading Chapter 1 of Practical Guide to Linux Commands, Editing, and Shell Programming, 3rd edition. Read the first chapter, which is titled Welcome to Linux and Mac OS X. That's available in the Safari book section on the ACM website, so you'll need to get your student membership to ACM, and remember that you at minimum need the basic student membership, the $19 one. You're of course free to get any of the higher level if you want the print magazine or access to the complete history of ACM articles and journals and all that. But the $19 student membership will get you access to the books. And then on Blackboard, under the course materials, you'll see a week 1 folder, and in there the quiz number 1. So you'll want to take quiz number 1, and that's of course due by Sunday night at midnight. Posted on Blackboard are the instructions for installing a Linux virtual machine using VirtualBox. You don't have to use VirtualBox. That's just the cheapest because it's open source and free. But if you already have VMware or Parallels or something like that, you're free to use that as well. But you'll want to get your Linux virtual machine, or if you have a spare computer and have or would like to install Linux on actual hardware, you're free to do that as well. But remember, at the end of it, if you have it installed already, or if you're installing a VirtualBox, bring it up, bring up a terminal, and run the uname -a command in the terminal, and then take a screenshot of that for me and post it in the discussion board. For that, so that I can see that you've got that going and that you're successful. And of course, if you have any questions about VirtualBox or any of the other software, or questions about installing or using Linux up to this point, be sure to post them in the discussion as well. And I will see you on the Blackboard, and I will talk to you again next week.